Look at this cliff face. It looks exactly like a stream of glowing, molten lava pouring straight down a sheer granite drop. For nearly a century, tourists were actually witnessing a man-made stunt. People were literally tossing burning wood off the top of a mountain. In 1872, a local hotel owner named James Macaulay devised a way to attract visitors. He gathered the bark of red fir trees, built a massive bonfire on the edge of a 3,000-foot precipice, and kicked the glowing coals into the canyon below. Raining thousands of burning embers into a dry forest carries obvious risks. After decades of severe environmental damage and the constant threat of forest fires, the U.S. government permanently banned the practice in 1968. 5 years later, wildlife photographer Galen Rowell pointed his camera at a different cliff in the park and captured this: a thin, glowing orange stream, nature's authentic, entirely solar-powered version of the same illusion. Creating this effect requires a sequence of improbable environmental variables to align at the exact same moment. The first requirement is spatial. Yosemite National Park encompasses over 3,000 square kilometers of pristine, ancient wilderness. This map of the park boundaries shows that the total footprint is deceptive. The phenomenon is physically constrained to an 18 square kilometer zone called Yosemite Valley. 99% of the park is untouched by this event. At a planetary scale, we can see why. During the last 2 weeks of February, the Earth perfectly angles on its axis, allowing a single unobstructed solar ray to strike that microscopic target on the valley floor. Because this viewing corridor is so small, it forces a severe bottleneck. Tens of thousands of international tourists cram into this tiny sliver of the park just to catch a glimpse. Getting the planetary geometry to hit a compressed area sets the stage. But the sun angle alone cannot forge the illusion of liquid fire. To change the color of the light, we look down at the valley floor, which is populated by millennia-old giant sequoia trees. These trees are biological engines. Every day, they pump millions of gallons of latent moisture upward, venting it from the canopy into the surrounding air. This cross-section of the valley shows how that moisture accumulates. It forms a dense grid of water vapor, acting like a massive natural glass lens suspended over the valley. When the incoming white sunlight hits this moisture grid, the biological lens goes to work. It intercepts the light and strips away the cooler blue and green wavelengths. What survives this filter are the longer red and orange rays. The lens intensifies them, focusing a concentrated beam of warm light directly onto the cascading waterfall. We have the solar geometry and the biological color filter. Yet, even with these systems aligned, the entire setup can fail due to a final vulnerability. Conditions now shift from the valley floor to the absolute peak of the rock formation, where Horsetail Fall originates. This waterfall has a geographical flaw. It has no permanent water source. The stream is fed by melting snow resting at the summit. This line chart plots the mountain's temperature as we approach sunset. The critical threshold is 0 degrees Celsius. We are looking at a 30-minute window right before the sun's rays hit the cliff. If a temperature drop, barely 2 degrees Celsius, pulls the summit below that freezing threshold 30 minutes before sunset, everything stops. The snowmelt crystallizes, the water source vanishes, and photographers watch as the waterfall dries up in mid-air right before the light arrives. But if that summit temperature remains above freezing, the thermal margin clears. The sequence is complete. For 10 minutes, the tumbling water meets the focused red light. A stream of natural fire pours down the face of El Capitan. We can map the mechanics of this anomaly, but our presence in the park carries a consequence for the ecosystem. Thousands of people entering the forest in the dark introduce heavy noise and light. This disrupts the hunting patterns of nocturnal predators, like the great gray owl. The crowd also displaces rare local mammals, such as the Sierra Nevada bighorn sheep, forcing them out of their habitats while they are already struggling to survive the winter. This density of people within just 1% of the park stresses the soil and habitats surrounding the giant sequoias. By crowding the valley floor, we risk damaging the environment these ancient trees need to survive. The Yosemite Firefall is a delicate interplay of planetary orbit, of towering trees, and freezing temperatures. To appreciate this natural masterpiece, we must ensure we aren't damaging the biological machine that regulates the valley and sustains the illusion.